Part 2, this is for questions 7 to 11. And number 7 is coming from trigonometry. We are supposed to show that this on the left hand side is equal to this. Okay, now we are going to use the left hand side to prove the right hand side. Okay, tan theta out of 1 plus cosine of theta, then plus this is tan of theta out of 1 minus cosine of theta. I need to get the common denominator, so I'll multiply these two. We use the butterfly method. Then you get this one times this, and then you also get this one times that. So what shall we have? Tan of theta times 1 minus the cosine of theta. Then we have tan of theta times 1 plus the cosine of theta. Then we are dividing by 1 plus cos theta, then 1 minus cosine of theta. Now this one is a difference of two squares, not so. So when we open the brackets here, we shall have tan of theta, then minus tan theta, cosine of theta, then plus tan theta, then plus tan theta, cos theta. Then we divide by, this is a difference of two squares, so when you open, you will get 1 minus cos squared of theta. In other words, I just get 1, square it, then minus, I put the cos of theta, then squared, okay? Difference of two squares. Okay, then after this, what are we going to have? This one will cancel with that, so we shall have 2 tan of theta. Then we divide by this one here, okay? 1 minus cos squared theta is actually the same as sine squared what? Theta, not so. What else do we have? Tan is the same as sine out of the cosine. Then times, there is sine squared theta here, so we shall have 1 over sine squared theta. Now here, this sine will cancel with 1 sine here, and then we shall remain with 2, then out of, there is a cosine of theta here, then times 1 sine of theta that remains there. And this is exactly what they have told us to prove. So that is that. Part B, hence solve this equation. Hence means begin from where you have stopped. This whole thing, we have seen it is 2 out of sine theta cos theta. Then we shall equate to 6 out of tan of theta. Now we shall cross multiply, and then here we shall get 2. I can even simplify this, okay? And we say, okay, let me just write 2 tan theta is equal to 6 sine theta cosine of theta. Of course, 2 will go here 3 times, right? So we shall have sine of theta out of cosine of theta, that is the tan theta. Then is equal to, when I divide all through by 2, I will get a 3 here. Then sine theta, then cosine of theta. There is a mistake here. Someone can divide all through by sine theta. When you divide all through by sine theta and you kill it, you are going to kill a solution. So you don't do that when it comes to solution of equations. You pull everything on one side, you factorize, okay? So you cross multiply. Here we shall get sine theta, which is equal to 3 sine theta, then cos squared theta, okay? Then from there, I can pull everything to this side. You can have sine of theta minus 3, but cos squared theta can be written in terms of sine theta, not so. Sine theta, or I can even leave it, not so. I can leave it. Let me just leave it in terms of cos, because I'm going to pull out the sine. So sine of theta is common. Then here you'll have a 1, then minus, here we shall remain with a 3, then cos squared of theta, which is equal to 0. Now we shall get sine of theta, which is equal to 0, and then our theta shall be equal to the arc sine of 0. Then this one will give you 0 degrees, 100, and all horizontal angles 180 degrees, 360 degrees, like that. Then 1 minus 3 cos squared theta is equal to 0. We shall have 1 is equal to 3, then cos squared of theta, and then this will be a third, which is equal to cos squared of theta. You take the square root, that means cos of theta can be equal to plus or minus the square root of 1 over 3. So meaning you have cos of theta, which is equal to 1 over the square root of 3, and also cos of theta, which is equal to negative 1 out of the square root of 3. Remember, whenever you take the square root, you have to consider a plus or the minus. Then your theta here is going to be the arc cos of 1 over root of 3. Then your theta here is going to be the arc cos of negative 1 out of root of 3. So cosine is negative in the second quadrant and third quadrant. Now in the third quadrant, there we are having angles which are greater than 180. So we are just supposed to have angles that are from 0 to 180. So this one here will give me the acute angle, then this one will give me the obtuse angle in the second quadrant. Okay, so what do we get here? The calculator has to be in degrees because our domain is given in degrees. Okay, so I'll change this to degrees, shift, then mod, and then degrees is 3, then shift cos, and then we have 1 out of the square root of 3. This one is giving us 54.7 degrees. Then this one here, so I will just come back to this and then I put a negative there, then that is 125.3 degrees. So this simply implies that my theta is going to be, here I'm not picking any angle because 0 is not included, 180 is not included. Okay, so I will have 54.7 degrees and then 125.3 degrees. All of these answers at 1 decimal place, and that is that. The first term of a progression is sine squared theta, where theta ranges from 0 to pi over 2. That is the first quadrant. The second term of the progression is sine squared theta times cos squared theta. And they are saying part A, given that the progression is geometric, find the sum to infinity. Now, for the sum to infinity, it is given by A out of 1 minus R. So we need to first look at the first term. We need A and then the R. So the first term, A, is given as sine squared theta. Then the second term, that one is AR, is given by sine squared theta, then cos squared theta. So meaning the common ratio R is equal to the second term divided by the first term. So we shall have sine squared theta cos squared theta divided by the first term, which is what? Sine squared theta, and you will have it as cos squared what? Theta. So meaning the sum to infinity, which is equal to A out of 1 minus R, our A is sine squared theta, then out of 1 minus our R is cos squared theta. Now 1 minus, even if you leave your answer here, they can give you the back, but let us simplify it. This is sine squared theta, then out of 1 minus cos squared theta is sine squared theta. So sine squared theta out of sine squared theta automatically will give you what? A 1. So the answer is a 1 here. As simple as that. It is now given instead that the progression is arithmetic. Part B, Roman 1, find the common difference of the progression in terms of sine theta. Now, part B is also under this term here. Okay, this is the whole stem of the question. So the first term is this one, and the second term is this one here. So the first term, which is also denoted as A, that one is equal to sine squared theta. Then the second term, which is denoted as A plus D, that one is sine squared theta, then cos squared what? Theta. So this will simply imply that the common ratio, the common difference, this one is now called the common difference. The common difference D shall be equal to the second term, which is sine squared cos squared theta. We subtract the first term, which is sine squared theta. And then you can see here that sine squared theta is common. Okay, so sine squared theta, if it is common, I'll factorize it. Then that means here I'm left with cos squared theta, then minus what? 1. Now remember they said that we have to put it in terms of sine theta. Now we know that cos squared theta is the same as 1 minus sine squared theta when there is a minus 1. So this minus 1 will cancel with this 1 here. Then minus sine squared theta will multiply with this sine squared theta. And then the answer becomes, we shall get our D as negative sine to the power of 4 of theta. And that is that. Then Roman 2, find the sum of the first 16 terms when theta is equal to pi. Now, sum of first n terms is equal to n over 2 into 2a, then plus n minus 1d. So we need, our n is 16, we need the first term. So first term is sine squared. So sine of, this is pi over 3, not so? Then we do what? We square it. So sine of 60 is root 3 over 2. When we square this one, we shall get a 3, then out of 4. Then the common difference, we have seen it is negative sine, then power 4. So you will get this one here, then you put power 4. So this will be root of 3 over 2. There's a minus here, remember, then power 4. So this is the same as saying this one squared is this. So I'll have 3 over 4, then squared. Not so. Yes, because you have root of 3 over 2 squared, then squared to give you this power 4. So that one will give us 9 over 16. So negative 9 out of 16. There is a minus here. That minus doesn't go with this. Okay. So sum of the first n terms of an AP is given by n over 2 into 2a, then plus n minus 1d. Not so? So what is our n? So sum of the first 16 terms, n is 16, then out of 2. Then we have 2 times a, which is 3 out of 4. Then plus 16 minus 1, that will be a 15. And then times our d, which is negative 9 out of what? 16. Okay, so this will be 8. And then we shall have this one as 3 over 2. And then minus 15 times 10, that is 150, minus 15, that is 135, right? 135 over 16. Now putting everything in the calculator, what we have, 8 into 1.5, then minus 135 out of 16. Then we close. This one is negative 111 over 2, which can be negative 55, negative 55.5, and that is that. Question 9. The functions f and g are defined by, this is what we are having here, but express f of x in the form, this one here. So there are two methods I'm going to use, like I've always done. So completing squares right away, and then also expanding, and then we equate the coefficients. So we have our f of x here, which is equal to x squared minus 4x, then plus 3. Now suppose I have x minus, let's say, b squared, and I'm expanding this one. This one will give us x squared, then minus 2bx, then plus b squared. I want one side to have the x's, so that means I'll take this one this side. So I'll have x minus b squared, then minus b squared here, then will be equal to x squared minus 2bx. Okay, now from here, look at the coefficient of x here. It is minus 2b. Now it was divided by 2, and then it was put inside here and also here. Okay, so we have minus 2b, then divide by 2, then we put it inside here, and we also pop it here. So this is the same thing we are going to do here. The coefficient of x here, divide it by 2, you will have a minus 2. So you put it inside here, you square, then you pop it out here, you have minus 2 squared. So we are always having a minus here because you have seen this one is crossing the equal signs. You see that? Then there is a plus 3, which is here. So this means that our f of x now is going to be x minus 2 squared, and then this is 3 minus 4, you get a negative 1, and that becomes our answer there. So meaning our a is a 2, if you see here, and then our b is a negative 1. Okay, alternatively, by expanding and equating coefficients, we shall also have the same answer. So you have x squared minus 4x plus 3. This one is the same as, now you equate to this one here, x minus a, then squared, then plus b. Then we open the brackets on the right hand side. That will be x squared minus 2ax, then plus a squared, then plus b. The coefficient of x squared is a 1. Even here it is a 1. Then the coefficient of x here is a negative 4. But then the coefficient of x this side is a minus 2a. So that means when I divide all through by negative 2, then our a becomes a positive 2. Then the constant here is a 3. Okay, that 3 then is equal to the constant part here. Our a is already 2, so we shall have 2 squared, then plus b. Now 2 squared is a 4. When it crosses the equal signs, it becomes a minus. That means our b is going to be equal to negative what? 1. Then you conclude and you say this x squared minus 4x then plus 3 is actually the same as x then minus. Now replace this a with the 2. So you put a 2, then squared, and then plus the b, but b is a negative 1. So minus 1, as simple as that. Choose the method that is easier for you. Then they are saying here it is given that f is a one-to-one function, and then part B, state the smallest possible value of c. Okay, now a function is one-to-one. First of all, look at this one here. It is a quadratic function. Okay, if it's a quadratic function, it is u-shaped. Are we there? This function is u-shaped, and its turning point is going to be, you get this one and you equate it to 0, you will get a 2. So 2, and then the y coordinate will be this one. That's a negative 1. Okay. Now, it has been coming like this, but then it changes the direction and goes like that. So meaning that we can have one y coordinate for two x coordinates. You see that? Now, this one is many then to 1. Okay? Many x coordinates are giving an output of one y coordinate. So that one cannot have an inverse. So a function is said to have an inverse only if it is 1 to 1. That means to make this function 1 to 1, then we need to either choose the left side of the turning point or the right side of the turning point. You see that? So as it talked about here, they said x greater than c. So we are looking at the right side of this turning point. Okay, so the smallest possible value of c at which this function is a 1-to-1 is at the turning point, because this is where the function is now becoming, it is changing the direction. Okay, so since we are considering only this part, so we have to consider from this part here, this point here, and then we follow this graph here. So that means each x coordinate will give to one y coordinate, x coordinate to one y coordinate. Okay, each of them will assign to a unique value, so it becomes a 1-to-1. So therefore, you get that x minus 2 inside the brackets here, you equate it to 0, and then your x becomes a 2. So therefore, your smallest possible value, because these are values of x, the c, they said x is greater than c, where c is a constant. You see that? So that one has to be a 2. It is the x coordinate of the turning point. That is the smallest possible value for which a function has an inverse. Okay, here they have said f is 1-to-1. They can bring this question again and they say that state the smallest possible value of c for which the function has an inverse. It is the same thing. You look at the x coordinate at the turning point. Is that clear? All right. It is now given that c is equal to 5. Part C, find an expression for the inverse of x and state the domain of the inverse. Now, suppose I let my f inverse to be equal to y. Take the f this side. That means I will have x is equal to f of y. That is the same thing as saying interchanging x and y. Okay, what is our f of x? Our f of x is actually this one here. Okay, so where there is x, I'm going to replace it with a y. Okay, so that will be y minus 2 squared, then minus 1. Then now you can make y the subject of the formula. You cannot find the inverse of a quadratic function if it is not in the completed square format. So if it is in this expanded format, you can't. Okay, you have to use the quadratic, the completed square format. So make y the subject, bring this on this side, it becomes a plus, so that will be x plus 1, then which is equal to y minus 2, then squared, then you take the square root, you have x plus 1, and when you take the square root, we shall have plus or minus. Okay, then y minus 2, then bring this to this side, that means we shall have positive 2, then plus or minus root of x plus 1, which is equal to y. Now, the inverse of the function here will be equal to 2. Then we have a square root here of x plus 1. Okay. Now, here you have to choose a sign. Do you take the plus or do you take the minus? You don't write plus or minus here because a function is said to have an inverse only if it is a 1-to-1, like I've said before. So that means you choose a sign here. That sign here is going to be a plus. Why is it a plus? Go back and look at the domain of the function given here. So they are looking at the right side of the turning point. So if they are looking at the right side of the turning point, then you choose a plus. If they are looking at the left side of the turning point, then you choose a minus. Okay, as simple as that. However, we can prove this. and then you see what happens here. Suppose I have, remember, we are using x now greater than 2. So let us pick a value. Let's say x is equal to 3. So what is f of 3? F of 3, we are substituting where? Into here. So 3 minus 2, then we square that. 3 minus 2, that will be a 1. We square, that will be 1. Then minus 1, that one will give us a 0. Now, you have a function, okay? Oh, it changed. It is now given that c is equal to what? 5. Okay, pardon me there. So x has to be greater than 5. So let me use that. F is greater than 5. Therefore, we should use this one, maybe a 6. Okay. X is equal to 6. So 6 minus 2. What do you get? 4 squared, 16 minus 1, 15. Okay. Now, we need f inverse of 15. F inverse of 15, what do we get? By the way, I need to change this one to a 6 to be systematic. So f inverse of 15, you have 2, then you put this one here, then where there is x, you are putting 15, then plus 1. That is 16. Root of 16, what do you get? Don't you get 4? You get 4. Now my question is, am I putting here a minus or a plus to get back the 6 here? It has to be a plus, not so. So we are putting the plus here for us to have the 6. So that is why here we are having a plus, but you don't need to do all of this. Okay, you don't need to do all of this in the exam. Just look at the domain which is given for the function. We are looking at the right side of the turning point. So if we are looking at the right side of the turning point, we take the plus sign. If we are looking at the left side of the turning point, then we take the minus sign. As simple as that. Now we come back to this. We are having our sketch here. Okay, we are having our sketch there, and the turning point is 2, negative 1. Now we are given c is equal to 5, so that x is now equal to 5. So at x is equal to 5, what will be the value of f here? So for x is equal to 5, then f of 5 is going to be 5 minus 2, and I'm substituting in here 5 minus 2, that one will give us a 4 squared. No, that will be 3 squared, that will be 9, then minus 1, we get 8. So that means this value here is 8. Now we are looking at values from here going this side. That means you will get 8 and then above. It is now no longer going to be negative 1. So because we extended to this other side here, you see that? So this means that the range of f is going to be, we are beginning from 8. So f of x is going to be greater than 8. Now I'm not putting or equal because 5 is not included right from here. If you check back where so I need to remove that. If you check here, they said that x has to be greater than, remember part A and part B, they are all under this stem of this question. They said greater than 5. Okay, so we are not supposed to consider that 5. So this one here is supposed to be the range. Now we have a set of values here of x, then f acts on them, then what comes out is the f of what? Of x. So the set of input values, we call it the domain. So that means this one is the domain of f. And then what comes out, the set of output values, is what we call the range of what? F. Then inverse is the function which undoes what a function has done, not so. So this simply implies that the set of input values for the inverse, of course, that is what you are putting in here. So this one has to be the domain of the inverse. And then what comes out is the range. So the range of f inverse. So what does this mean? The domain of f is the range of the inverse. And then the domain of the inverse is the range of f. Okay? Now, from here, domain, because they told us to write the domain of the inverse. Domain is written in terms of the independent variable. Just like here, this is the domain, okay? It is written in terms of the independent variable, that is the x. Then the range is written in terms of the function, that is the output, okay? Now, this one here, it's the range of f. It is written in terms of the what? The function, you can see there. But then when I'm writing the domain, I have to take away the f of x and then I replace it with x. So I will have x greater than 8. That is that. Then part D, find an expression for gf of x and state the range of g of x. Now, we have g of x. That means we are composing. In fact, let me write these functions here. The g of x was given as 1 over x plus 1. Then f of x, we got it as x minus 2 squared, then minus 1. Now g, f of x means that we put f of x in the place of x in the g, okay? So that means we shall have 1 over, where there is x, I'm putting this. So that will be f of x, then plus 1. So we have 1 over x minus 2 squared minus 1, but then there is a plus 1 here. So plus 1. So we get 1 out of x minus 2 squared. So that is our answer here. Okay. Then what else? They want us to find the range of, now this one is what we call a reciprocal graph. So reciprocal graphs go like this. You find if you have something like this, they can be like that, and then there's a mirror in here, so they mirror themselves like that, or you can have one here and then one here. Now, what do we have here? We are going to look at these values. Okay, you are putting g of x, you are putting f into the g. Let us have something here. So x is here, then f first acts on it, and then what do you get here? F of x. Then the f of x is acted on, so the result here is acted on by the g of x, meaning we shall have g f of x here. Now remember, okay, so from here up to here, that is gf. So remember, if I'm to put f into the g, then remember what comes out of here. This is the domain of f, this is the range of f. Now what we put into the function has to be in its domain, okay? So the range of f must fit into the domain of g in order to compose f into the g. Does that make sense? What is here must fit in the domain of g such that you substitute in the function of g, then to get the output, okay? So what is the domain of, so what comes out here will be the range of g. We have range of f In fact, I can say range of GF. Okay, that is what comes out here. But this one must be contained in the domain of G. And then here we are having domain of F. Now we need to set the range of the G of X. We are given G of X as 1 over X plus 1, okay? And then F of X is given as X minus 2 squared minus 1, not so. Now our G F of X, we have seen it is 1 over X minus 2, then squared. But the domain, if you are composing F into the G, then the range of F must fit into the domain of what? Into the domain of G, not so? Now, they said that the domain of G, let me write it here, domain of G is given as X greater than negative 1, okay? Now, we have found a new function, the GF. So, for now X greater than, for X, let's say, is equal to negative 1, what do we get? Okay, our GF of negative 1 will be 1 over negative 1 minus 2 squared. This one will be 1 over 9. Okay, now any value that we are getting here greater than negative 1, we can put 0. So when you put 0 here, you get 1 over 4, not so? That is 0.25. Then you get big positive values here. That means this whole thing keeps on increasing and increasing down here. So that means your answer will tend to a 0. 1 over a very big number tends to a 0. You see that? So because of that, this simply implies that we shall have, I will say for now X greater than negative 1, the GF of X, okay, will tend to the 0. Will not be 0, but will tend to the 0. That is why when you draw such graphs, you see something coming like that. It is the x-axis becomes an asymptote to the curve. An asymptote is a line that is not crossed by the curve. You see that? So this simply implies that our domain, our range of G of X, range of G of F, okay, this one is going to be, of course, this one is bigger than the what? The 0. So you write the smaller one, 0, then less than, we have the GF of X, and then less than 1 over 9. Okay, this one is not included because they said it is greater than what? Negative 1. So I use the negative 1 just to get the value that comes out of here. You see that? Yeah, but it is not included. That's why I'm putting less than that. You see? Because this one, the value keeps on what? The values keep on decreasing. So we have the 1 over 9 when X is equal to negative 1, and then the rest keep on decreasing. So this is going to be our final answer, and that is that. Question 10 part A. The coordinates of the 2 points A and B are these ones here respectively. They show that the equation of the perpendicular bisector of AB is this one here. There are two things you need to know. Number one is that a perpendicular bisector passes through the midpoint of a line segment. Let me write it here. A perpendicular bisector passes through the midpoint of a line segment. And of course, we also have to find the gradient of that perpendicular bisector. And you know that lines are perpendicular. For two lines which are perpendicular, then the product of their gradients is always equal to negative 1. That's why we write m1, m2 is equal to negative 1. So we need now to find the midpoint of AB So this one will be the average of the x coordinates, negative 7 plus 5. That will be a negative 2. Then divide by 2, you get a negative 1. Then what else? We have 5. The average of the y coordinates, we have 3 plus 11, which will be 14. Divide by 2, then you get a 7. So we have negative 1 and then the 7. So that's the first mark you're going to get there. Then number 2, by the way, I have these coordinates here. So let's say this is our A, negative 7, 3. Then this is our B, 5, then 11. Then the midpoint here, we have seen the midpoint is negative 1, then 7. Okay, this is the perpendicular bisector. So we need M1, that is the gradient of AB. So change in y, that is 11 minus 3, over change in x, which is 5 minus 7. So this one will give us 8, then divide by 8, 12. That means here we shall get by 4, 2, by 4, 3. Not so? Then the gradient of the perpendicular bisector will be negative 1 over the gradient of the line AB, 2 over 3. Then we shall get negative 3 out of 2. Okay? Then from there, to find the equation of a straight line, we need the gradient and at least one point through which a line passes. We have the gradient, we have a point through which the line passes. So now using y minus y1, which is equal to m into x minus x1, we are using which point? Negative 1, 7. So y minus our y1 is a 7, and then our m is negative 3 over 2, then x, and then our x1 is negative 1 here. So we cross multiply. This one will give us 2y, then minus 14, which is equal to the negative 3 times the x here. When we open the brackets, that will be negative 3x. And then this one will be a plus, then times this minus, which will be a minus, right? So minus 3. And then this one, actually, let me write, this one becomes a plus. So we shall have now x and y put on one side. You have 2y, then plus the 3x. Then this one is equal to, when this one crosses, it will be a plus. So you have minus 3, then plus the 14. Now, don't you think that we are having what we are looking for? 3x here, then plus the 2y, then this one will be equal to 11. As simple as that. Part B, a circle passes through A and B and its center lies on this line here. Find the equation of the circle. Now, you should know that if you have a circle here, okay, and I have a center of that circle, now we have this one here. Let's see if the gradient of this line is negative or positive. This will be 12x, then minus 70 is equal to 5y, then divide all through by 5. So that means y will be equal to 12 over 5 of x, and then minus 70 over 5. So this one is a positive gradient, the coefficient of x. So that means this line, I'm assuming, can be like that, because lines which are positive can slant like that, which are having the positive gradient. Then the ones which are negative can slant like that. Not so? Now, they are saying that the center lies on this line. Okay, so that's why I'm drawing it and I'm making it pass through the center. So I'll say that this one here is 12x minus 5y, then this one is equal to 70. Then they said that A and B, the circle passes through A and B. Now, if I have, let's say, my A here, which is negative 7, 3, it was given as negative 7, 3, and then B, B was given as 511. Okay, see the way I even drew it here. This is -1, I mean -7. Then this is 5. 5 is on the right of -7, and then this is 3, and then 11 is above. So that's why I put A here and then the B here. You see that? So my B, let me maybe place it here. B is 511. 5 511, like that. I connect this, let's say, to that point B there. Now, from circle theorems, you remember that if you have a chord here, let's say this is A, this is B, then the perpendicular line from the center always bisects the chord. Okay, so this one is going to be the perpendicular bisector of the AB. It will always pass through the center. Why? Because this one here is an isosceles triangle. You have R and then R. So this one automatically has to pass through the center of the circle. So any perpendicular bisector of a chord passes through the center. Okay, so I will say any perpendicular bisector, of a chord, okay, passes through the center of the circle. So what does this mean? We shall get the perpendicular bisector of AB, okay, which is like that. Then it has to pass through the center of that circle. So this is the perpendicular bisector of the chord AB, whose equation we got it. The perpendicular bisector of AB, we got it as what? This is 3x plus 2y is equal to 11. So 3x plus 2y is equal to 11. This means we are going to solve these two equations simultaneously. Then we get the coordinates of the center of the circle. Is that clear? So solving 3x and 2y is equal to 11 and 12x minus 5y is equal to 70 simultaneously gives the center of the circle. Now I can have 12x minus 5y then is equal to 70. This is 3x plus 2y is equal to 11. I can multiply. I'm using elimination to solve these two. Okay, I can multiply this one by 4 such that the coefficient of x here becomes a 12 as this one, so that I can eliminate x. So that means we have 12x here minus 5y, which is equal to 70, and then 12x plus 8y, which is equal to 44. When I subtract, because the coefficient of x is the same in here and here, okay? Now, minus 5 minus 8, that one gives us a minus 13 of y. And then 70 minus 44, isn't that a 26? Yes, 26. That means y will be equal to negative what? 2. So if y is a negative 2, then what will be the x coordinate when we substitute in any of the two equations? So maybe I use this one here, 3x, then plus 2, y is a negative 2, then this one is equal to 11, and then 3x will be equal to, this is a negative 4. When it crosses, it adds to the 11, then you get a 15. That means x will be equal to 5. So that means the center of that circle is 5, then negative 2. Are we there? Then from there, we are supposed to find the radius, because to find the equation of the circle, you need the center and the radius. Now, I can use this center here, okay? And any of these coordinates, I can use this or this one, okay? So let me use B and the center. So using B, which is 5, is it 511? Yes, 511. And the center here, which is 5, negative 2, radius will be equal to, the change in x will be 5, okay, minus 5. Since the x coordinate is the same, then we shall go to the y. Then 11 minus 2. So this one is a 0. This one is a 13. 13 squared. Then you take the square root. Then you get 13. Not so. Then what else do we get here? The equation of the circle is going to be x, then minus the 5 here, squared, then plus y minus 2. So it will be a plus 2 squared, which is equal to 13, then squared. So meaning our final answer becomes x minus 5 squared, then plus y plus 2 squared, which is equal to 169. This becomes the answer. Question 11. The diagram shows part of the curve with this equation here and the line OA, where OA is the maximum point on the curve. The x-coordinate of A is small a, and the curve has a minimum point at B0, where A and B are positive constants. Okay, now part A shows that B is equal to 3A. Now we know that for stationary points, then dy dx is equal to what? 0. Not so. So this is our y here, and then dy dx is going to be 3x squared. So we have 3x squared, then minus 4bx, and then plus b squared. This one should be equal to 0. Okay? Now, at A is the stationary point here, because it is maximum here. Okay? At A, which is small a and then 0, we can substitute in here. Where there is x, then we put the a. So we shall have 3a squared minus 4b times a, then plus b squared is equal to 0. Not so? Now, here we are going to have a quadratic formula. It is a quadratic equation in terms of a. So 3a squared, I think I don't even need to write this, because this is the coefficient of a here. Now, let us solve this equation. Okay, let's use the quadratic formula to solve this. So our a is going to be equal to minus b. What is the b? That is the coefficient of a here. That is minus 4b, then plus or minus to the root of b squared. That will be minus 4b, then squared minus 4. Then our a will be the coefficient of a squared here, which is 3. And then our c is the b squared. Not so. Then we divide by the 2. Then a is the 3 here. So this one will give us a positive 4b, then plus or minus. Inside here we shall have 16b squared, and then minus, this will be 12b squared out of 6. Then what else do we get here? 16 minus 12, that is 4b squared. So 4b, then plus or minus root of 4b squared. Now, this one gives us 2b, okay, or 6. This is all equal to what? To a. And then If I want to get A, this one will be 4B, then plus 2B out of 6. Or A can be equal to 4B minus 2B out of 6. So this is 6B out of 6. That one will be a B. Then here, now 4B minus 2B, that will be a 2B, then over 6. Of course, this one will be now 1 over 3, so B over 3. Not so. Now from here, don't you see that when I cross multiply, then my B will be equal to 3A. And that is what they wanted me to show. So that is that. B is equal to 3A. Part B, show that the area of the shaded region between the line and the curve is K a power 4, where K is a fraction to be found. Okay. Now, when we look at this shaded area here, we shall get area under this curve, okay, minus area of this triangle. You see that? So when x is equal to a, what will be the y coordinate here? We shall substitute in here, okay? So I'll say at a, okay, x is equal to a. So what will be y? Y is going to be, we have x cubed, so our x is a. Now a cubed minus, we have 2bx squared, 2b, then x squared, so that will be a squared, and then plus b squared, then times the a. So this one will actually become, this is a cubed, okay, this is a cubed. Now you have your b. We have just found that b is equal to 3a, not so? So we are going to substitute it here, a cubed, then minus 2b. Now the b is a 3a, then a squared, then plus 3a squared, then times a. So you have a cubed, then minus, this is 6a cubed, okay? 6a cubed, then plus 9a cubed. Now 9 plus 1, that is 10 minus 6, then that 4. That is 4a cubed. So this therefore implies that we have our a, the coordinates of a, as 4, no. We have a, and then the y coordinate is 4a what? Cubed. So I need to find area under the curve. So shaded area, I said area under the curve, that is from 0 here to a, okay? 0 to a, and then we need to integrate the y, okay? So I need to first get my y here in terms of what? In terms of a. So let me take this one down, and then I say if we have y which is equal to x cubed, then minus 2b, remember, is 3a. A, I'm substituting here, b, then we have x squared, and then plus 3a, that is the b squared of x. So that means here we shall have x cubed minus 6a x squared, then plus 9a squared of x. You see that? So that is what we are now going to substitute here. 0 to a, and then our y is x cubed minus 6a x squared, then plus 9a squared of x, like that, with respect to x, then plus area of the triangle. Okay, area of the triangle, a half times the base, here is a, and then the height will be the value of y we have gotten when we substituted the a, which is 4a what? Cubed. You see that? So in fact, it is a minus, then area of the triangle. In fact, let me write this one like this so that you follow clearly. So this one is going to be the shaded area is equal to area under the curve up to a, then minus area of the triangle. Okay, so area of the triangle is a half times the base is a, then the height is 4a what? Cubed. Okay, why is it 4a cubed? Remember, when you come here, this is a, and then that is what? The y coordinate here is 4a cubed, which we got. So area under this curve is the whole of this. Then we put off the area of this triangle. You see that? Then we integrate now here. So when you begin the process of integration, you take away the integral sign. So replace it with the square brackets. Increase the power by 1, divide by the new power. Okay, then you have 6a x cubed, then out of 3. That means this one will cancel with that, then you get a 2. So I'll write 2a, then x cubed. Then plus I'll have 9a squared, then x squared out of the 2. And then we put a, and then 0. Then this one will go to 4 will be reduced by the 2. So you have 2, then a power 4. Then now we put the limits here. So when I put the limits, where there is x, I will put a, so a power 4 over 4 minus 2a. Then I'll put a here, then cubed, then plus a, 9a squared, then a squared, then out of 2, like that, then minus, there is an x here, an x here, an x here. So when you replace them with a 0, you'll have a 0, then minus the 2, a power 4. And then you can see here that you have a quarter, then you have a 2 here, then you have a 9 here over 2. All of these ones have a power 4, and then 2 here. Now, in fact, I can have 1 over 4 minus 2, then plus 9 over 2. Then there is minus 2 here, because all of them have gotten a power 4. So if I factorize it out, now what do we get altogether here? 1 out of 4 minus 2, then plus 9 out of 2, and then minus 2. We get 3 out of 4. So we have 3 out of 4 of a to the power of 4. That is our answer. And in fact, they said that it has to be this, where k is a fraction to be found. That means k is 3 out of 4. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, then like, share, or even subscribe. See you in the next videos.